Okay, so let us have the second option, solving quadratic inequalities by graphical method. So we are now in graphical method. So the same given. So you have to remember that when you graph a quadratic, it is two things. It could be this graph or this graph. Now, it depends on the value of your A here. So in this case, the value of our A is positive. So therefore, the graph will be opening upward. If your value of your A is negative, so the graph will be downward. Okay, so the same as tabular method, you will make this as an equation, factor this so that we could get the critical values. So your critical values are x equals 5 and x equals minus 1. All you need to do is you plot this as you draw this as a quadratic. So take note, our A is positive, so the graph will be upward like this. So we will graph it, opening upward. Where my values are, let's say this is minus 1, and here is 5. So take note, example, this is your real number line, okay? So if your real number line is, this is your x-axis, and then this is your, so you have 0 here. So this is your x and y axis. Now here, what do we need? So what do we need depends on this, less than 0. Now, if it's less than 0, we need below the x-axis. If it's greater than 0, so we need above the x-axis. So our given is less than 0. So what do we need? If this is your x-axis, we need below the x-axis. What is that below the x-axis? Based on the graph is this one. So this one. This is the only value of the graph which is below the x-axis. So your solution, what is this value? From minus 1 to 5. So your solution is from minus 1 to 5. No equal sign because the given, it doesn't have an equal sign. Okay. Now, let us have the second example. Now, in your second example, we have the same given. However, 1 minute, I will check. Okay, so we have the same given. However, here we want greater than 0. So if it's greater than 0, we will take above the x-axis. So that means what is above this value? This orange, this. So what is this value? And also this value above. So your solution is the values which are less than minus 1 or the values greater than 5. Because you wanted this one, take note, this could extend to the left, and this one, this will extend also to the right. So x less than minus 1 or x greater than 5. Okay, let's have another one, example. So the same thing with the previous method. You need to arrange this first. So 2x squared minus 5x plus 3 is less than 0. Now, I'm not good with factorizing negative. I'm not also good if the graph is opening upward. So what will I do is, I will remove the negative by dividing everything with minus 1. So this will become positive, positive, negative, and if it's negative, this will change the sign. Now, I have now my new inequality, so I can continue solving by finding my critical values. How? Making it as an equation and factorizing this. So what will be the factor? 2xx plus 3 minus 1. And so equating all the factors by 0. So this will be my first critical value, and then this is my second critical values. So again, I will draw a real number, a Cartesian plane. So example, this is my x-axis, and then here is minus 3, and 1/2 will be here. All I need to do is now my new inequality, A is positive, so opening upward. Okay, now we have now the graph. So we can identify now the inequality. What do I need? I need the values greater than 0. So greater than zeros are the values above the x-axis. So I need this one and this one. So that will be my solution. This is minus 3 and this is 1/2. So my solution are the values left of minus 3 or the values right of 1/2 or 0.5. Okay. Now, again, if you have like this and like this, the same, you will solve it individually and graph in a real number line. So we will solve this. So this will be minus x squared plus 4x plus 12 greater than 0. I don't like negative. I will divide everything by minus 1. So this will be x squared minus 4x minus 12. This will change the inequality. Make it an equation and factor. So x minus 6, x plus 2. So my critical values are 6 and minus 2. So I will draw a Cartesian plane. Here, let's say, is my minus 2. Here is my 6. Connect, opening upward because my new inequality here is positive. So this will give me opening upward. Okay? Now, what do I need? I need the value less than 0. Less than 0 is below the x-axis. So I want this one, which is, this is minus 2. So my x first value is from minus 2 to 6. I will solve this also. Dividing both sides by 5. So x greater than 1. So I have my two solutions. So the same as what we did with the tabular method, you will plot it in one line, one graph like this. So minus 2 to 6, your first solution. And your second solution is greater than 1. You identify where they are together. And so the solution is from 1 to 6. Okay, let's have the last example. So you have quadratic. So solve it as an equation. X minus 5, x minus 2. So my critical values are x equals 2 and x equals 5. So if this is 2 and this is 5, opening upward because my A is positive. Now what do I need? Less than 0. Where is less than 0? below the x-axis, this one. So my solution is from 2 to 5. For this one, you will solve it also individually. 17 minus 5. So 12 divided by 3, x less than 4. So you have two solutions. You just have to plot it in the real number line like this. So your first solution is from 2 to 5. 2 to 5, this one, open. Your second solution, great less than 4. This one, less than 4. You identify where they are together. So the final solution is, this is your end part, where they are together. So therefore, your solution is from 2 to 4. Okay. That's it for quadratic inequalities.